Today we're going to do problems and solutions of 2.3 exponential functions. We'll start with question number 1. Consider the table of values for the function y equals 2 times 1/3 to the power of x. If we try to observe from the table, x is from -5 to +5, while y is from 486 to 2 over 243. We want to identify if the values of y are increasing or decreasing as x increases. So the y is from 486, that is when x equals -5. But when x increases, we can see here the y decreases because it's already 2 over 243. If we want to convert that into a decimal, that is in decimal form. I mean, less than 1. Okay? So describe the behavior of the function as x increases. So as x increases, as x increases, we could say the function decreases, right? How does it decrease? Did it decrease fast? I think at a slower rate. Slower and slower rate. We can see that the equation has a constant factor of 1/3 that is less than 1. So the equation has a constant factor of less than 1. So this is why the function is, I could say that the function is decreasing. Okay, by looking at the table, we know. Determine the y-intercept of the function. Remember, the y-intercept, of course, y-intercept happens when x equals 0, right? So from the table, we could say that the y-intercept is happening when x is 0. That means the y-intercept of the function is at 0, 2. We can see that the equation has the leading coefficient of 2 right there. Then this value of y-intercept and the result of substituting x equals 0 into the equation. State the domain. Domain, it refers to our x value. The domain is the complete set of possible values for x. Any number that could be the x value for exponential function. The graph extends indefinitely in both horizontal direction, whether it's to the right infinity or to the left infinity. So we could say that our domain is to the right infinity and to the left infinity. Okay, so I will write this from left infinity to right infinity. That means the domain are all real numbers. That's for the domain. For the range, all exponential equation in the range, that would be y equals a times b to the power of x have a domain of all real numbers. Okay, this is range. Sorry for that. I was still thinking of the range. So the range, as we see, is the complete set of possible values of y right here. So anything goes for the possible value of y as to what will be our input. So we can see the graph extend indefinitely up towards the left, but approaches as asymptote as y equals 0 towards the right. Okay, so y here should be greater than 0. Y should be greater than 0 because as the graph extends indefinitely to the left, up towards the left, and approaches asymptote, when it approaches as asymptote, when the y equals 0 towards the right. Because this is in a decimal point towards the right, its positive value until it reaches to 0 value. So y is greater than 0 at this point in the graph. Okay. Let's have the second number here. A large puddle of water starts evaporating when the sun shines directly on it. The amount of water in the puddle over time is shown in the table. Hours since sun came out and the volume in ml. So we have 0 to 5 and it's 10:24. There is a space what would be after 3 hours and after 5 hours. So given that the relationship is exponential, complete the table of values. So we want to know the constant factor from here, right? So that means if we want to get the value of b, for that, we can have 512 over 1024, which is 1/2. Right? Using the value of b, for b, we know that the volume after 3 hours will be 256 over 2, which is 128. And also for 5 hours, that would be 64 over 2, which is equals to 32. So the exponential function is example of one that decreases over time. So here the domain is, say, x is greater than equals to 0 because it would not make sense to have a negative values for time. Alright? When this happens, we refer to the y-intercept as the initial value. Okay, so we have completed a table. B, describe the relationship between the time and volume. We found that previously that b is 1/2, right? So that tells us how we move from one term to the next term. So from 1024, it is 512. That means 1024 divided by 2 to get 112. So the volume of water is half every hour. So we could say that, okay, for every increase in time, by 1 hour, the amount of water is what is divided by 2. Okay, let's have this number. Answer the question for its exponential function. So before doing that, I want to get a quick review of what is going to happen when in terms of limit as a greater than or b greater than to this. Okay, so in this case, let's say if you have an xy coordinate here and the graph goes that way. Remember in the previous video, when a is greater than 0 and b is greater than 1, the graph goes curving up and opens up left. So doing the as x approaches positive infinity, what happened to the function? The function, it will be approaches, you look at that going up, the function is positive infinity. While on the left side, as x approaches negative infinity, I wrote it wrong. As x approaches negative infinity, that is to the left, the function of x, what happened to the x here? It will get closer and closer and closer and closer until it is equals to 0. That's the case. While a is greater than 0, but b is less than 1, what's gonna happen? It looks, the curve looks like this. This is a greater than 0, but the b is less than 1. So what happened? As x approaches positive infinity right here, the function, it gets closer and closer until it will approach to or equal to 0. While here, as x approaches negative infinity, the function of x is equals to positive infinity. There, going up positive. Okay, let's have this. We have a curve going that way. What's going on in this curve here? A would be less than 1 and B greater than 1. Right. As x approaches positive infinity, the function of x is going down equals to negative infinity. While here, as x approaches negative infinity, the function of x, look at the direction, as it approaches to 0. Well, on the other side, if the graph goes that way, what is going on here? A less than 1 and B is less than 1. So the graph as x approaches positive infinity, this time it goes that way until it is going to equals to 0. While here, as x approaches negative infinity, the function is equals to negative infinity. That is the case. So in letter A, we have 1/5 for the B. So the B here is less than 1. So what would our graph looks like? It looks like that, because it's less than, the B is less than 1. So the function is the function increasing, decreasing? The function is decreasing. So if the function is concave, is the function concave up or down? It's concave up. Okay? For the limit, when x approaches negative infinity, all right, the function of x is infinity. In the case right here, this case. And for the limit when x approaches positive infinity, the f of x is 0. All right. Let's have this. Our a is greater than 1. Our b is greater than 1. Both are greater. So our graph goes that way. Okay? Because both are greater. So the function is increasing. Right? It is concave up. It's concave up. So the limit as x approaches negative infinity, the function is 0. When x approaches positive infinity, the function is infinity. Look at that, going up. So it's positive infinity. All right. That answers for question number 3. Let's have question number 4. Consider the exponential function of y equals 2.5 and 4 to the power of x. So if it look at our a is greater than 1, the b is greater than 1. So we know how our graph looks like. The curve looks like that. It is increasing and it's concave up. It's facing up. Okay, draw the graph of the function, and we can identify both intercept and a constant factor from the equation, since it is in the form of y equals, okay, y equals a b to the power of x. So using this, what features that we can use? Plot other points to the left and the right of the y-intercept and connect it in the smooth curve. Now take note that the function has a constant factor of 4, since it has the base exponent, and the y-intercept, look at this, the y-intercept is at 0 and 2.5. That is the coefficient, right? Since that is the a, so that means at this point, this is where the coefficient is located. I mean, the point for that is located in the graph. So we have here as the initial point, all right, where the 0, 2.5 is located. Now we know that the constant factor is 4. So if we want to go from, I have a negative 2 and 2 right here using for that. So that we could go up at least, let's say, I'm going to use first 2.5. What happened when I have 2.5? I'm going to use all these points here on the domain, 4 to the power of 2. So what do you have? 2.5 times 16. The y value would be 40. Okay? So when it's 2, it is 40. So I can see now where my graph goes. So let's get some more points. If I use 1, y 2.5 times 4 to the first power. So 2.5 times 4, I will get the value of 10, right? So it will be 10 right here. So which one I didn't use yet? Negative 1. Y would be 2.5 times 4 to the negative 1. That would be when we have, a negative exponent, we want to get the reciprocal for that to make it into a positive. So y is 2.5 divided by 4. And that is, how much would that be? I'm using the calculator here for a while. 2.5 divided by 4. I have a 0.625 in the maybe somewhere here when it's negative 1 right here. All right, then I will draw the graph now. I will use another color for that to give us a nice view of the graph. There you go. All right. So you have the graph. You can check this graph using the calculator. Okay? I know everyone knows how to use the calculator when we are doing the graph. Okay, consider, go to the next number. Consider the exponential function f of x equals 2 to the times 1/3 x. So we are given f of x equals 2 times 1/3 to the power of x, and g of x equals 3 times 1/2 to the power of x. Using the table of values, draw the graph of f of x and g of x on the same plane. All right, let's have the table of values before going to that. Let's say, okay, the best way to do is like, I have the x value I could start with, this is f of x, negative 3. Then I could have negative 2, negative 1, 0, 1, 2. I think that would be enough to get the value. Oh, I have a very long here. Okay. So what am I going to do? I will substitute that to get the f of x. 2 times 1/3 to the power of negative 3. You know, when you have a negative exponent, you have to get the reciprocal, right? This is so that the exponent will be positive. So this will be 2 times 3 to the third power and get the reciprocal of it. That is 27. So that would be 54. All right. Do the same thing. 2 times 1/3 to the negative 2. So you come up with 2, making it into a positive. 2 times 9, that would become 18. Same thing with 2 to the first power. 1/3 to the first, that would be 2 times 3. That's equals to 6. For 0, exponent is equals to 1. 2 times 1/3 to the 0, 2 times 1, that's equals to 2. All right. Doing the same thing with 1, you come up with 2 over 3. I will not write it anymore here. With 2, 2 over 9. That would be your graph. That would be your points for the graph. So doing the same thing for here, x, and this is g of x. When it's negative 3, 3 g of x would be 3 times 1/2 to the power of negative 1/3. So 3, get the reciprocal, that is 2 to the power of 3. That is 2 times 2 times 2, that's 8. 3 times 8, that is 24. When it's negative 2, you have 3 times 1/2 to the power of negative 2. Get the reciprocal and multiply 3 times 4. That would be 12. When it's negative 1, do the same thing. 2 times to the first 1/2 to the negative 1. Get the reciprocal. That is equals to 6. When it's 0, 2 times 2, 3 times 2, okay, it's 3. Because you have 2 to the 1/2 to the first power, 0, that is equals to 1. So 1, you have 3 over 2. When it's 2, you have 3 over 4. So these are your coordinates. Let's say we plotted it. Okay, this is now the graph of the g of x and the f of x. We can see that as x increases, both f of x decreases. Okay, as x increases, both the f of x and g of x decreases. Decrease. Um, Determine which function is decreasing at a slower rate. Okay, we can compare the constant factor to help determine if the function is lower rate. The factor of, okay, I'm gonna write the function again. F of x is 2 to the 1 times 1/3 to the power of x, while g of x is 3 times 1/2 to the power of x. We can see that as we approach 0 from left, its unit value in x, f of x is decreasing by a factor of 3, while g of x is also decreasing by a factor of 2. This means that, what does it means? F of x is approaching 0 faster. Right? Approaching. Zero faster than what? G of x. I was looking at the graph. So we could say, therefore, g of x is decreasing at a slower rate. All right. Okay, consider the following exponential function. We have the value of x from -2 to +2, and the g of x is -9 to -1/9. Determine which function increases at a slower rate. Okay, as I've said, one way to determine by comparing the constant factors. So we can find the constant factors by dividing the output of two consecutive. So we could use the points of negative, when it's -1, because we have f of x here, and this is j of x. So we can see the f of x from here. When it's -1, it is 8, right? And we can use this as 0 and -2. So that means we can have the, using the -1 and -8, and 0, negative 2 from f of x. Okay, so we could get the common factor by negative 2 over negative 8, we have 1/4. For g of x, okay, g of x, let's get the common, the factor. So for g of x, we can use the negative 3 over negative 9, this one right here. We have 1/3. So we could say that 1/4, this is the factor for f of x, is less than 1/3, right? So this means that it gets multiplied by a smaller factor. What's going on here? I can raise this. Smaller factor than g of x. Because of this, we could say that f of x will get closer to 0 faster than g of x as it increases at slower rate. So this is by looking at the graph, you are asked to determine which function it increases at a slower rate. So from there, we could say that g of x increases at a slower rate. From this graph right here, this is the g of x and this is the f of x. So by using the table, like this table right here, we can plot this graph. So let's say it's pre-plotted already. When it's negative 2, it's 9 right here. When it's negative 1, it is negative 3. When it's 0, it's negative 1. When it's 1, it's 1/3. And when it's 2, it's negative 1/9. Right? That is how the graph is being plotted. So when we look at the graph, we can see that g of x does not seem as steep as f of x, and its curve is more rounded. So this visual indication that it is increasing at a slower rate. So increasing at a slower rate. Identify the y-intercept for its function. Okay, let's see the y-intercept here. Right here, the g of x. Okay, the y-intercept of f of x. When x equals 0, it's at negative 2. 0, negative 2 in the graph. Well, the g of x, the y-intercept of g of x is at 0, negative 1 from the graph right there. All right. So now we can use the y-intercept and constant factor for each. So we could build, say if you're asked to build the equation, you could say that the f of x is negative 2 from the y-intercept times 1/4 to the power of x, while the g of x, you could say negative 1 from the y-intercept times 1/3 to the power of x. Okay? All right. Let's do this. It's a multiple choice. Looking at the table, the exponential f is defined by f of x, where a and b are positive constant. The table gives a value of f of x at selected values of x. So which of the following statements is true? A, demonstrate an... Okay, so let's look at this first. If we try to observe A, B, C, D, one says exponential decay and the other one says exponential growth. So if we look at our output, 40 to 20, 20 to 10, 10 to 5, 5 over 2. So that means if we have 40 divided by 2, it's 20. 20 divided by 2, that's 10. 10 divided by 2, that's 5. 5 divided by 2, that's 5 over 2. So it's not growth because it's decreasing. So that means the C and D, you can eliminate that right away because it's talking about growth. And the table does not demonstrate an exponential growth. It demonstrates an exponential decay. So our choice would be either A or B. So let's check. A demonstrates an exponential decay because A is greater than 0 and B is less than 1. Okay, A is greater than 0, B is less than 1. This is the one. Because it's exponential decay, A is greater than 0, but B should not be greater than 1. Alright, that's it. The function h is a function of the form h of x equals a times b to the power of x, where a is not equal to 0 and b is greater than 1. The function h is also given by h of x equals f of x plus 2. So if you could see this plus 2, there is a translation taking place. Okay? So it says, which of the following statements is true? The output values for both f and h are proportional over equal length input value interval. It's not because of this. The output values of f only, not h, are proportional over the length input value. F only? No, it's not. The output values of h only, not f, are proportional over the equal length input value interval. Correct. Why? Since the h of x equals a times b to the power of x, this means h is proportional. H is also the additive transformation of the function of f. Additive transformation. Therefore, f must be exponential, but we don't know if f is proportional. Okay? We don't know if f is proportional. It's neither. F or h are proportional, so it's not the answer for that. Okay? So we're done. Let me say this, if I can do it, so can you. Please don't forget to hit the like button and subscribe button. See you in my next video.